Welcome to Unit 2, Reasoning and Proof. Our first learning goal for Unit 2 is that students can use inductive reasoning to make reasonable conjectures and find counterexamples. Those are probably all new vocabulary terms, so it might not mean much to you. So we're going to actually talk about those vocabulary words before we would rate ourselves at a 1, 2, 3, or 4. So Lesson 2.1 is over inductive reasoning. So before we can start, we need to know some vocabulary words. The first vocab word is inductive reasoning. Inductive reasoning uses examples to predict what comes next. So you will actually look at examples in order to make a prediction on what would come next. A conjecture is an unproven statement based on observations. So a conjecture is that you're looking at those examples and you're going to observe them, and then you're going to make a statement based on what you see. And then last but not least, we have counterexample. A counterexample is a false example to prove a conjecture is not true. So it's an example that would prove a statement not true. So here's what we mean by the word conjecture. Make a conjecture about the next item in each sequence by sketching the figure. So we're actually going to be using inductive reasoning because we're going to be looking at examples, looking at this pattern, and then we're going to make a conjecture about what item will become next in the sequence. So if we look at A is a triangle which has 3 sides. Then we have a square. The square has 4 sides. Then we have a pentagon. The pentagon has 5 sides. And so I would make a conjecture based on my observations that our next object would have 6 sides. So I would draw a hexagon. On B, you would look at that pattern and you would look at all 3 of those. And you would notice that the first one, we have a set of vertical lines with a circle in the middle. Then those vertical lines become horizontal, and then we have 2 circles. And then they go back to vertical, and we have 3 circles. And so the next one, I would make a conjecture that those lines would go back to horizontal. And instead of 3 circles, I would now have 4 circles. So we're making a conjecture by looking at that pattern. So same thing here, we're going to make a conjecture about the next item in each sequence by predicting the next number. So we're going to look at our pattern, we're going to make some observations, and then we will then determine what we think our next number is, which would be our conjecture. So we go from 2 to 4, 4 to 12, 12 to 48, and 48 to 240. So I'm looking at that pattern and I ask myself, okay, what pattern am I noticing? Well, I notice that to get from 2 to 4, I multiply by 2. To get from 4 to 12, I multiply by 3. To get from 12 to 48, I multiply by 4. And then from 48 to 240, I multiplied by 5. And so then I would take 240 times 6, and that would give me my conjecture, or what I think my next item in that sequence would be, which would be 1,440. If we look at B, we have 17, 15, 12, and 8. To get from 17 to 15, I subtracted 2. To get from 15 to 12, I subtracted 3. To get from 12 to 8, I subtracted 4. And then to get from 8 to my next number, I believe I would subtract 5. So my conjecture would be 8 minus 5, which is 3. So my conjecture would be 3. Example 3 says make a conjecture about each geometric relationship. So part A says the product of 2 even numbers. So I'm going to make a conjecture. So in other words, I need to look at examples to determine what I know or what I think I know about the product of two even numbers. So in this case, we're going to have to look at two even numbers and take their product. So you can just start making yourself a list. 2 is even and 8 is even. So I'm going to find the product of 2 and 8, which is 16. Then let's say maybe I pick 10 and 6, which are both even. 10 times 6 is 60. Then maybe I choose 4 and 12. 4 and 12 is 48. Then maybe I choose 14 and 4. That's 56. So I'm going to look at all of my products and I'm going to say, okay, what do I notice about all of the products of all those even numbers? Well, I noticed that all of those products are also even. So my conjecture would be, after looking at those examples, the product of two even numbers is even, because in every single example, every time I took the product of two even numbers, that product was also even. So that would be my conjecture based on the examples I looked at. Part B says the relationship between A, B, and E, F. So I want to make a conjecture about the relationship between A, B, and E, F. If I know that AB is equal to CD, so in other words, I have AB, segment AB, it is the same exact length as segment CD. So notice those tick marks would indicate that those two segments are the same length. So I know that AB is equal to CD, but I also know that CD is also equivalent to EF. So what I notice is that all three of those segments end up being the same length because we see that CD is the same length as AB, but CD is also the same length as EF, so I could conclude that AB and EF are also the same length based on my pictures there. So my conjecture would be if AB equals CD and CD equals EF, then I can conclude that AB is also the same length as EF. And looking at those pictures really helped us solidify because we were able to see those tick marks and verify that AB and EF would also be the same exact length. So we're just looking at examples to make a conjecture. For example 4, we're going to determine if each conjecture is true or false. So a conjecture has already been made and we're going to determine if it's true or false. If it's false, we're going to provide a counterexample, or in other words, an example that proves the statement false. So example 4a says the difference of two positive numbers is positive. So we have to determine, is that conjecture true or false? And the way we do that is we're going to look at specific cases to see if we can provide a counterexample, and you're going to see that this one is actually false. If we look at two positive numbers and we find the difference, meaning we're going to subtract them, we're going to find two positive numbers that when we find the difference, that their answer is not positive. That would prove this to be a false conjecture. So my counterexample would be if I found the difference of 5 and 10. Those are both positive numbers. And if I take 5 minus 10, I get -5. And -5 is not positive. Therefore, this proves this false because the difference of 5 and 10 is negative. For example B, it says the sum of two negative numbers is negative. And so I'm going to think of some examples. And after thinking of examples, we're going to verify, is this true or false? And in this case, this is going to be true. And the reason we know this to be true is if we think of any two negative numbers, let's just say -1 and -2. If I find the sum of those, anytime I'm adding two negative numbers together, if I borrow $1 and then borrow $2 more, I'm just making my number more negative. So anytime I'm adding two negative numbers together, I'm just making that sum more negative. So that is always going to be true. And our last two examples. The same thing. Determine if each of these conjectures is true or false. If it's false, we're going to provide a counterexample. So example C says, given that angle 1 and angle 2 are supplementary, our conjecture is that angle 1 or angle 2 is obtuse. And so we have to think of some examples to kind of help us determine the validity of this statement. So first of all, we have to know what supplementary means. So we're saying that angle 1 and angle 2 add up to be 180 degrees. So that we have to know what that word means first. So I have two angles that add up to 180 degrees. So the conjecture is that angle 1 or angle 2 is obtuse. And that can be true. That totally can be true. If I have a 20-degree angle and I have a 160-degree angle, my 160-degree angle is definitely obtuse. However, I could also have two 90-degree angles, and we know that 90 degrees plus 90 degrees will give me my 180, so those two would be supplementary, but neither one of those is obtuse. So this example, the conjecture is false, and my counterexample would be that both angles could be 90 degrees. So my counterexample is that angle 1 and angle 2 could both be right angles because 90 degrees plus 90 degrees is 180. And then last but not least, given that angle 1 is a right angle, my conjecture would be that the measure of angle 1 is 90 degrees. And obviously, if angle 1 is a right angle, then obviously angle 1 measures 90 degrees, so this would be true. There is no example that would prove that to be false, so that one would be true.